Today we are seeing another PYQ question from GATE, which comes in the year of 2020 from the topic process synchronization, and it is available on practicepaper.in. If you choose operating system section, then you will see question number 34 on the website, and you can solve it, practice with it, share with your friends. All right. So let's see what question says. Each each of set of n processes, there are n processes in a set following a code using two semaphores. There are two semaphores A and B, which are initialized to 1 and 0. A is initialized to 1 and B is initialized to 0, respectively. Assume that count is a shared variable initialized to 0. There is a variable count which is initialized to 0, not used in code section P. This count variable is not used in code section P. So the code section P is not a critical section. All right. So let's solve this question. What does code achieve? Okay. Let's assume there is a let's assume n is equal to 4, n is equal to 3. Let's take less. We have to do less calculations. But you will understand all the answer. Let's say there is a problem process P1 wants to exit the critical section, and it executes from here. Code section P executes wait A. If we perform wait A, then value of wait A becomes 0. We will perform count plus 1, increment operation on count will become 1. If count is n, count is not n, then it will skip this instruction. Signal A, signal A. So here is a question arise. If P2 wants to access the critical section at before P1 signals A, then it can't enter because the value of A was 0. And if P2 performs wait operation while the value of A is 0, then it becomes negative and P2 will go to sleep state. All right. And it can't access the critical section. So if P1 signals A, then it will allow P2 to critical access the critical section. And firstly, then it will P1 will perform wait operation on B. It will become -1, and P1 goes to sleep state. It can hold here. P1 will stop here. Then P2 can access the critical section. So we'll perform wait operation on A from by P2. It will become 0. Then count on 1. It will become 2. If count is n, no. Signal A, signal A. Wait B, wait B. It will become in -1. And P2 also goes to sleep state. And if P3 wants to exit the critical section, it will wait, perform wait operation on A, it becomes 0. It will count on increment on count, it becomes 3. If count is n, yes, signal B, it can signal B now, it becomes 0. Signal A, from 0, then but the value of b should be 0 always here. It will not go to negative. So now if P3 performs signal operation on B, then it will become 1 and it's a positive number. Then if we perform wait operation on B by any process it become 0 and signal B will become 1. Now P1 connects its section Q and then P3 also perform wait operation will become 0, then signal operation and execute the code section Q and as well as P2 and P3. So it will perform all the operations. What does code achieve? It is lets it from it ensures that no process executes code section Q before process has finished code section P. Yes, no one was allowed to exit code section P until all the processes execute the code section P. So it is right. So we can say that it could be correct. Yes, it is correct. And we can see the more explanation of the problem on Gate Overflow. By click, we can access the website from there only. If count is equal to false, then it should not input zero, 0. Yeah, I said that, but I firstly forgot the concept that B was not, we will not go to the negative. It will always remain 0. So, yeah, thank you for watching and keep uh, supporting us. Uh, we will do more practice questions on this channel. Thank you so much.